Welcome to the CBT on generation of electricity from coal. By the end of this lesson, you will be familiar with basics of power generation, coal for power station, coal transportation, and generation of electricity from coal. Now let us see the basics of generation of electricity in a thermal power plant. A thermal power plant is a power generation unit using coal as the main fuel. The chemical energy of the coal is converted into thermal energy by the combustion of coal, and thermal energy is transferred to the working fluid, water or steam in the boiler. High pressure and high temperature steam from the boiler flows through the turbine where the useful work is produced by the expansion of steam. Turbine works as a prime mover for the generator, which is directly coupled to the turbine. Generator conductors rotating in the magnetic field generates electricity. Electricity generated at the generator terminal then flows through the transmission network. Let us first discuss about the coal and its properties. Coal is a naturally occurring combustible material consisting primarily of the element carbon with low percentages of solid, liquid and gaseous hydrocarbons and other materials such as compounds of nitrogen and sulfur. Coal is usually classified into the subgroups known as anthracite, bituminous, lignite and subbituminous. The physical, chemical and other properties of coal vary considerably from sample to sample. Coal is extracted from the coal mines, which are of two types. They are surface mines and underground mines. Surface mining can be used when a coal seam is close enough to the earth's surface to allow the overburden to be removed economically. Underground mining is used when seams of coal are located at significant depths below the earth's surface. Coal is transported from coal mines to the power plant by means of rail transport. Special wagons are used for coal transportation. Each thermal power project has been linked to a particular coal mine to meet its coal requirements. The required coal is supplied through rail wagon to the power plant. If the thermal power station is away from coal mines, then the coal is fed through Indian Railway system, or otherwise for pit head station it is done through merry-go-round railway system. A 500 megawatt steam generator consumes about 8,000 tons of coal every day. Now let us see the unloading of coal from BOBR wagons in track hopper. First, the coal wagon has to be placed on the hopper. After placing the wagons on the hopper, electrical pulse is given to the pneumatic device for opening the bottom doors. Immediately, coal is emptied on track hopper. This coal falls on a T-table over which a plough feeder rotates and feeds the coal to a moving conveyor. Now let us see the unloading of coal using wagon tippler. The tippler is designed to unload the coal by inverting the wagon on its own center of gravity through an angle of 170 degrees, thereby discharging the coal into the hopper. The tippler is designed to handle wagons having a gross load up to 110 tons. Unloading the box and wagons through the wagon tippler takes more time because only one wagon can be unloaded at a time. During unloading, the wagon needs to be disconnected from the rest of the wagons, whereas unloading at track hopper through BOBR wagons is very fast because number of wagons can be unloaded simultaneously depending upon the length of the track hopper. Now let us see the working principle of tippler. The loaded wagon is placed on the tippler platform. After correct placement of wagon, top clamps and side beam are hydraulically operated and the wagon is clamped before starting the tippling operation. The hydraulic system incorporates a pressure relief which balances the pressure of the wagon springs, thus avoiding any damage to the wagon. Now the tippler is rotated to an angle of 170 degrees, and due to the rotation of tippler, the coal inside the wagon starts falling down on the T-table. The T-table is a girded structure over which a paddle feeder runs and pushes the coal onto a conveyor. Now let us see how the coal is used to generate the steam. From the coal handling plant, the coal is transported to the main plant through the conveyor and fed to the individual bunkers by tripper. Then, from the coal bunker, the coal is fed to the pulverizer or mill at a regulated rate by raw coal feeder. In the pulverizer, the coal is pulverized to powder form of a desired fineness. Primary air fan sucks atmospheric air and supplies pressurized air to pulverizer. Prior to reaching the pulverizer, primary air is preheated in the primary air preheater by utilizing the heat of exit flue gas. The primary air dries out the surface moisture of the coal and carries the pulverized coal through coal pipes to the furnace. Simultaneously, the secondary air from the forced draft fan is also sent to the furnace for combustion, after being heated to a desired temperature in the secondary air preheater by utilizing the heat of exit flue gas. Air preheaters are located after the economizer in the flue gas flow path. The water from the boiler feed pump passes through the economizer. Economizer preheats the water using the heat of flue gas in the second pass of the boiler. The water then enters into the boiler drum, from where it flows down to the bottom of the furnace through insulated pipes called downcomers. Water then enters into the water walls, which forms the walls of the first pass of the furnace. Here, the boiling of water takes place and two-phase mixture of water and steam reaches the boiler drum again through riser tubes connected to the water wall outlet header. Water and steam separation takes place in drum. Now, the saturated steam from the drum enters into the three stages of superheaters where steam is superheated. First superheater in the circuit is primary superheaters or low temperature superheaters. Then enters into the pendant superheater and finally passes through the final superheater before reaching the HP turbine. For a 500 megawatt turbine steam, we require steam flow of nearly 1530 tons per hour at a pressure of nearly 170 kilograms per square centimeter and a temperature of 540 degrees Celsius. The combustion of fuel produces hot gaseous products or flue gas in the boiler. These flue gases transfer their heat energy and pass through various heat-absorbing components in the boiler, an air preheater, and then go to electrostatic precipitator where the ash particles are extracted and finally pass through the chimney to the atmosphere. The superheated steam which comes out from the final superheater enters into the HB turbine, where it passes through the series of stationary and moving blades. Heat energy of steam is converted into mechanical energy due to expansion of steam in HB turbine. The turbine shaft usually rotates at 3000 revolutions per minute. This speed is required to drive two-pole generator for generating the alternating current at a frequency of 50 cycles per second. The electricity is usually produced in the stator windings of large modern generators at about 21 kV. But our transmission voltage level is usually 220 kV, 400 kV or 765 kV. Extra high voltage transmission is used to reduce the ohmic losses in the long distance transmission lines. Generating voltage is raised to transmission voltage with the help of generator transformer. Output of the generator transformer is connected to the transmission lines in switchyard, which houses various electrical equipments like transformers, circuit breakers, isolators, earth switches. This concludes the lesson on generation of electricity from coal.